How's it going, everybody? Welcome to another week of CS2304. Michael Irwin here, and this week we're going to be talking about persistence and adding kind of storage persistence to our pods. But this particular video, we're just doing a little bit of intro to the week, and so I'll start off with our meme for the week. And I'm sure that many of you have had this scenario before when it's 5 a.m. and you're not done with your essay, but you see the sun rising, and you can swap out essay with systems programming or any other fun thing to be working on. And yeah, that should say week 8 assignments due on Sunday. But this week there's going to be both a hands-on as well as another poll. And really, since we didn't have a poll last week, I don't have any poll results to go over. But I at least want to go over the quiz because quite a few of you got a couple of the questions wrong, and that's okay. It gives me good feedback on where we are and what things I need to cover a little bit more. So let's actually just go ahead and jump over to that. So I've got here the quiz summary. You can see that the average was a 72 for it. And what I'm going to do is actually go through each of the questions and just talk through them and explain why the answer is what it is. Okay, so for this first question, if I wanted to ensure I could deploy updates to my applications with a specific number of replicas, what type of object would I define? Okay, so let's go through them one by one first and talk about why it's not that. So a pod is just a simple app, and it doesn't let me do any sort of replica management or how many instances of it I want. So I know that's immediately not in. Replica set does let me do multiple replicas, but the big difference here is the part in the question that says that I could deploy updates to my application. So a replica set has much of the same limitations as a pod in the sense that you can only update so many aspects of it, because at the end of the day, a replica set is just templating pods and scaling up and down and how many there are. But it's the deployment that's kind of scaling back and forth how many of each replica set of each configuration we want. And so the ability to deploy updates is unique to the deployment. Okay, so that's why it's that one. And 87% of you got it right. So good job there. If I wanted to run a container on all nodes in my cluster, what type of object would I define? And the type of object that lets us define pods that will run on all nodes in the cluster, yep, that's daemon set. So that's the right answer there. If I wanted to ensure a pod ran a specific if I wanted to ensure a pod ran a specific number of instances or replicas, what type of object should I define? So in this case, we didn't talk anything about deployments or updates, that kind of stuff. And so if I wanted just a specific number of instances, then I could use a replica set. Now, I know I mentioned in the lecture that typically you're not going to define a replica set directly. Even if you weren't going to do updates to the application, you'd probably still use a deployment. But this particular question was, this whole quiz was kind of helping differentiate the differences between all the different object types. So that's why that one's the replica set. Okay. If I wanted to run a process on a regular schedule or interval, I would use a job. And this is false because what I would want to use is a cron job. The cron job lets you use cron, which if you're not familiar with Linux environments, cron lets you run things on a schedule. So they leverage the name as well. So cron jobs run a schedule, and yes, they actually launch jobs, but at the end of the day, you would be defining a cron job. So this one is false because I would actually use a cron job. Okay. When defining a deployment, all of the selector labels must be defined on the pod deployment. Now, this one, if you didn't know, you can also just try it out yourself. So let's actually try this one out, and I'm going to just make a quiz YAML here. And let's just make a deployment. app21 kind is a deployment. And let's just give this a name of quiz, and let's do a spec. Replicas, I'm just going to do one. And so I have to give it a selector. Match labels, and I'm just going to give it one to start with, app quiz. And then a template. And for right now, I'm not going to give it any labels, so I'll just give it an empty object. And we'll see what it fails, because our particular question is saying all the selector labels must be on the pod template. So maybe instead of an empty object, let's just give it something else. So app2, but name it the same, sure, whatever. And then let's give it a spec just so that we meet the object specification. And I'll just have it run Nginx. Okay, now if I try to apply this, it'll tell me that the deployment quiz is invalid. Spec template metadata labels invalid value. Okay, app Q2 quiz. What? Selector does not match template labels. So the selector, it's saying that the selector says that I should be matching labels of app quiz, but I didn't define app quiz. And so it's like, hey, you're defining a deployment with a selector that doesn't even match the thing that you're templating, and it prevents you from doing that. Okay. So going back to our question here, yes, defining a deployment, all of these selector labels must be defined on the pod template, and that is true. Okay. So with defining a deployment, the pod template can only have the labels that are defined as selector labels. And so let's actually try this one out. So what I'm going to do is first, maybe we'll just leave that one there, and we'll add another label and see if this works. Okay, it does in fact create it. And if I list out my pods, describe my pod, I'll see that the labels up here include both labels. So yeah, you can actually define as many labels as you want in your deployment. And so the selector has to be a subset or the entire set of whatever labels are on the pods, but you can define as many labels as you want. And in fact, many of our deployments that we typically have lots of labels on them, and the selector may only pick one or two of them. Okay. All right. This next one, where pods limited to the fields you can change, deployments let you change anything, and that is true. So you can really change anything, and that's the whole point of a deployment, lets you make changes. All right, and this one I know was a little tricky, and it threw people off. Okay, deployments automate the scaling up and down of pods directly to roll out changes. Now, so remember the way that that deployments work, and in fact, let's jump back over the terminal here, is if I look at my replica sets, I see a replica set for that deployment. And in fact, if I look at the pods, you'll see that the first part of the pod name is the replica set name. And then there's just a random identifier that the replica set puts on when it spins it up. Now, if let's split screen this here, and I'm gonna do a get watch here, and let's make a change to our. Oh, I accidentally opened the preferences there. Let's make a change to our deployment, and let's change our image to just plain Nginx. And what we'll see is that a new replica set will spin up, and the old one will wind down. And so what the deployment is doing at the end of the day isn't actually interacting with the pods directly. It's creating replica sets that have the right replica amount or replica values as we see it kind of scaling the desired counts. And it's simply changing those objects, which then as so when we spin up a new replica set, we say, all right, here's the new pod spec. I want one of these running. It defines that object, which then Kubernetes says, okay, cool. You've updated the replica set. Now let me spin up another replica. So the deployment at the end of the day is only automating the replica sets, which then they are automating the pods. And so I hope that makes sense how that's working. And that's what this question was getting at. So the deployments themselves aren't scaling up and down the pods directly, and that's why I put the directly name in there. It's not doing it directly. It's the replica sets that are actually doing the scaling up and down. So I recognize that most people got that one wrong, and that's okay. So if you got that wrong, don't worry about it. Okay. It wasn't meant to be a trick question, but I guess it kind of turned that into that. So sorry about that. All right, and then I wanted to go over the hands-on. I think for the most part, everybody that at least did the hands-on got the answers here, but I wanted to go through them real quick. So towards the end of the second section here, working with taints and tolerations, it says, as the following step, apply the following manifest and create the labels tolerations that are required to get the app up and running. And then once you have it, port forward one of the pods port 80 to see your flag. Okay, so I'm going to copy this qcutl apply command, and let's go back to my terminal, and I'll just go full screen terminal here. Let's kill some of this and clean it up a little bit. All right, so let's go ahead and just apply. And we'll see deployment got created, and if I look at the pods, I see that one is pending. And if I describe that pod, I'll get some errors here. It says that one node didn't match the pod's node affinity and selector. So if I scroll, let's see, does it actually display it in here? I guess it doesn't display it in here. It does give the tolerations, but I guess not the affinities. So what I can do is then get the pod and do it in the YAML output, and this will give me the affinity. So this is saying, all right, we're going to do a node affinity, and the following is required during scheduling, which would explain why we're not seeing the app start up. So we've got some node selectors that are required during scheduling. And if we look at the node selector terms, the match expression, so our node needs to have the following flags, or the following labels on it. So secret flag with a value of super secret. Interesting, okay. And then another label of course CS2304. So I'm going to leave this here, and I'm going to go split. So let's go the other direction. And I'm going to get my nodes, and I just have a single node here called Docker Desktop. And so I'm going to label the node Docker Desktop, and I'm going to say secret flag equals super secret. It says that the label's been created. If I look at the pod, it should still say that it's pending. And if I look at the pod, it'll still say that it doesn't match. Cool. All right, so now let's add the other label to it. Docker Desktop course equals CS2304. And now if I get the pods, I'll see that the app is running, so I don't need this top one anymore. Okay, port forward application, and it said that it was going to be port 80, so I'm going to use port 8080 of my host. And if I curl localhost 8080, I see my secret here. I could open up in the browser too, but that's all right. In fact, maybe let's do it. Why not? Okay, localhost 8080. Oops, I added a dashboard. Getting a redirect from something, probably some other app I was working on before. That's all right. But anyways, the terminal gave me my answer, so the answer, you figured it out. So that's my answer, and actually just kind of let me pull this up real quick. Just as a fun little quiz statistics. 60% of you didn't include the curly quotes, while the other 38% of you did. So, random fact there. All right, the other question, let's check it out. So init containers, in fact, actually, real quick, I'm going to just tear everything down. So, find my, grab that URL, and I'll delete that. Okay. All right, so init containers, blah, 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 and we scroll down here, here's our challenge. So with the information you obtain, you're going to do something very similar. The manifest below uses multiple init containers to configure a file that the final web server will serve. Once you have the pod working, you should be able to open it on port 80 at whatever your port number you map to /config/output.txt and see the answer. Okay. All right, so let's go ahead and apply this first and see what we get. So I'll switch to my terminal. Oops. Copy the whole command here. All right, and so this works. Now, so one of the things I can do, and if you ever want to look at one of these manifests directly in the browser, in this case, I'm going to use curl and just go fetch it and display it here in the terminal. But this will tell you exactly what's going on here. And we can see our application. So let's kind of talk through what we're looking at here, what we see here. So I have a deployment. The labels obviously are good because the deployment was created successfully. And I've got an init container here. In fact, I've got two init containers. Now remember that init containers are going to run sequentially in order and have to run to completion. So if any of them fails, then the next one's not going to run. And if I look at this, okay, so I see a volume mount, mount path of /config, interesting with an extra G there. But what we see is I'm going to echo just a string, hello world, to config/data.text. Be kind of interesting to see if this actually succeeds. We'll take a look at that here in a second, because I bet the /config directory doesn't exist because there's a typo here. And then the next one, what it's going to do is do now it's going to base64 config/dat.text. So it looks like another typo there. And it's going to, whatever the base64 output is going to go to /config/output.text. Okay. So the first one is creating a data file, and the second one is base64 encoding it. Okay. Interesting. And then our final container is going to mount that same volume at user share nginx HTML. So this is the web root for nginx, and at /config. So actually, kind of going back to the problem statement, it was saying, I'll pull this up real quick here, that /config/output.text, it looks like anyways, if I'm looking at this, since the /config directory is this volume, that the output.text file that we're getting here is what should be displayed as part of the web server. Okay. Now let's take a look at things. Let's list out my pods, and I see that I have a crash loop back off. All right, let's figure out what's going on here. So if I do logs, this will tell me it was waiting for a pod to initialize. Let's maybe start off by describing the pod and see if that gives us anything. I see that it created the container startup 1. It started, but I don't see that it's tried to do startup 2. So it looks like we're failing at startup 2. And if I scroll kind of through the rest of this, yeah, I don't really see much else. I never got a container ID for startup 2. So this kind of hints to me that, okay, startup 1 failed. And if I look at this, the state and the reason that the last state for startup 1 is terminated with an error status here. Okay, so with that in mind, let's go back to our logs, but let's specify the actual startup 1 container that we want here. And now if I look at this, the error message that it printed to the console is can't create config data.text non-existent directory. Okay, so like we were looking at the deployment, yeah, that typo is messing us up here. So let's edit our deployment, and let's go to startup 1. Where's my init containers? There we are. Okay, so startup 1. Let's fix that volume path. Remove one of the extra G's from it. Apply this. There's a problem with VI. Never seen that one. Okay. All right. Not sure what that problem was. I've never seen that happen before. Ran it again. Seemed to work. Okay. So now let's get our pods here. Okay. So now we're still getting an init crash loop. All right. Let's describe that pod. All right. So let's look at the startup 1. We do see that it terminated and it was completed. So that means it successfully finished its job. And if I look at startup 2, I do see a container ID. So that did actually try to start running, and I am getting the crash loop back off here now. Okay. And so let's look at, oops. I don't remember which, it's my latest one here. Okay. So, okay, logs, and let's do the startup 2 container and see what it says. So config dat.text, no such file or directory. Okay. So now I need to go fix the deployment again. All right, now it's edited. And just keep watching this. Okay, so now it says it's running. So it looks like that all of our init containers ran successfully. And if we look at the second init container, it does say it completed, it was terminated, and exit code is 0. If you're not familiar with exit codes, anything non-0 means failure. So 0 is a good exit code. And I see that the web server has started. Okay, cool. So now let's do a port forward. And let's do the same thing. And curl localhost 8080 config output.txt. And there's a base 64 value. And in fact, I could try to do base 64-D read from standard in, and I get hello there. And so I see that I get the original value back. So going back to the quiz, so that's our second answer there. And well, nobody got it wrong. that at least submitted anyway. So that's those were the hands-on and the quizzes from last week. Didn't get as many questions, so I hope it was a little bit easier to kind of go through and debug. So and I purposely try to put a couple of really simple gotchas, because a lot of times, at least with Kubernetes, in my experience anyways, has been a lot of just simple, oops, I fat fingered a command, or I messed something up, or I used the wrong service name and things didn't connect, or whatever. It's usually pretty small things for debugging. And again, since we're not really focusing on, in this class anyways, how to actually create container images and the applications, we're focusing more on the orchestration and the configuration and kind of the ops side of things. A lot of times it's going to be just small mistakes in the YAML. And so I'm going to continue to litter those mistakes throughout the class. And, and actually, if you take the certification, that's much of what the certification really is all about, is, okay, go define something that does this, or troubleshoot this other pod and why it's not working. And so if you keep up with the work here and you just kind of keep trying, and if you're figuring out these problems, you'll actually do really well on the certification. So anyways, that's enough for the intro for this week. Hopefully you're doing well. And as always, if you've got questions, feel free to reach out to me, and we'll go from there. Thanks. I'll see you later.